the more interesting question is, why did I do this? Is this of any value to us? So today, that, that that's where we're going to begin. We'll be going asking the question right here. Why did I do this? Yes, yes. Well, why do we care if I can plug in 1.999 or 1.999 and so forth and so on? And the answer to that question, I will actually go around answering the question. So go ahead, get your little fingers ready to type in the answer. Let's say I have this function right here. So consider, I have right here f of x is equal to x squared plus 6x plus 8. And I'm dividing this right here by x squared minus 4. I want you to find the answer to this right here, f of negative 2. Work this out. You are allowed to use a calculator and then send me a private text message, a private message telling me what is the answer to this thing right here. What do you get when you plug in negative 2 into this question? I got one answer already. That was fast. Oh, yeah, again, you are allowed to use a calculator. Right now, since we're not taking a test, you can use your cell phone if you want to, but it is highly recommended that you use your calculator that you plan on using on the test. I believe you can get a good price one from Walmart for like $10 a scientific calculator. If you can't go to Walmart, you might want to order it now so it gets here in a few days. So you have one to test move around. I got two answers. 3. Come on, they got like 17 of you. Again, if you're not sure, if you don't know what the answer is, or you're not sure what I'm asking you to, you can always send me a message saying I am not sure. That is fine. The key here is I want an answer from everybody. You know, it's part of your attendance and participation grade. By the way, calculators are tricky things. You do need to actually practice using a calculator. I can show you the same problem and have 3 people do it and all of them get a different answer using the same calculator. So you do have to be careful. Who am I missing? Who am I missing? I'm up to 10 people so far. You don't have to answer twice, you know. Oh, unless of course you're changing your answer. Miss Lawrence. Who am I waiting on? Who am I waiting on? All right. So to solve this problem right here, you plug negative 2 in. So you're going to have negative 2 squared plus 6 times negative 2 plus 8 divided by negative 2 squared minus 4, correct? Well, -2 squared is -2 times -2, and that is +4. A negative times a negative is positive, positive, positive. So that is 4. 6 times negative, a positive times a negative is negative. So 6 times 2 is -12 plus 8. And then again, the bottom, -2 squared is +4 minus 4. 4 minus 12 is -8. -8 plus 8 is 0. And in the denominator, 4 minus 4 is 0. And so I get here a 0 divided by 0. And as some people have correctly surmised, this right here is undefined. One cannot divide by 0. Okay? That's one of those little rules that we had to learn from back in the day. So, for example, I got this from the internet. It is okay when you have a number in the denominator, but no, you cannot divide by 0. See right here? So this is fine, but this you cannot do. If you have a 0 in the denominator, the answer does not exist. There is no, well, not doesn't exist. The answer is undefined. And we say undefined for a specific reason. The reason why we say undefined is we believe that there may be an answer, but we know we have to go ahead and try to find that answer. But we haven't discovered it yet, so if someone has, we'll be really happy with them. That's why we say it's undefined. So for my function right here, if I plug in -2, I don't get an answer. However, if I do this, if I find the limit as x approaches -2 for my function, well, what's that equal to? To get the answer to this right here, we have to kind of bring together everything that we did last time. So the first thing I have to do is I have to identify what limit I am taking. I am taking the limit as x approaches -2. And so what that means is that I have a number line. And on that number line, somewhere is the value 2. Actually, not somewhere. Right dead in the middle. Did I say 2? I meant to say -2. Now, somebody, give me a number, the next whole number that is on the left side of -2. Somebody tell me what the next number is.
-3.
That number is indeed -3. And if I start from -3 and I walk towards -2, numbers I will encounter will be, for example, -2.5, -2.9, -2.99, correct? Just from this number line right here, if I keep going from the left side. On the right side, somebody else tell me what's the next whole number over on the right side?
-1.
-1, that is correct. And so if I go from -1 and I start walking towards -2, I will encounter numbers like -1.5, wait a minute, I'm not right. These numbers are getting closer to 3, not 2. Hold on, I gotta fix this. That number line is not correct. -2.5. It should be -2. Be nice to me. Should be -2.1. -2.01. Yes? 0.99 is on the other side. So -1.9, -1.99. Yes? That's the red numbers are the left side. The right numbers, the blue numbers are on the right side. And so what I use this for is I then create a table of values. Y'all remember this from last time, right?
Yes.
Yeah, so the numbers that you plugged in on that number line, those are the same ones that we got from Tuesday?
Well, they're the same in terms of the decimal. But remember the last time I think we did we did 2. So there's 3 and
So,
mm-hmm.
okay. So is that just, so how did we get,
So for
are
example,
we just using,
so
that's just what,
yeah, so hold on. For example, if I have, for example, x is approaching 10, then my number line, I'll have a 10 in the middle right here, correct? Over here will be 9, 9.5, 9.9, and then over here will be 11, 10.5, 10.1, right? So it's whatever number limit I'm taking, that is the center number, and I approach that number on each side.
how are we getting the decimal numbers?
Oh, we just fall in the pattern of adding an extra.
How are you getting
Say again?
I'm just asking, how are you getting like the 9.5, the 9.9, the 10.1, 10.5? Like, how are you getting those decimals?
Well, this, first of all, this is a number line, correct?
Yeah.
So if I'm going in order on my number line, the first number I will meet is 9, right? And then between 9 and 10 would lie all of these decimals, right? 9.1, 9.2, 9.3, and so forth and so on, including 9.5 and 9.9. I'm trying to get close to 10, and so I'm going to be choosing numbers like this eventually, because each time I add a 9, I get closer to 10.
Okay.
Okay? And the same thing on the other side, 10.1, 10.01, 10.001. Each time those numbers are closer to 10. So with that being said right here, I'm putting together a number line, X and Y, and I have, say, what number comes first, -1 or -2? Let's put -3, then -2.5, -2.1, and -2.01, -1, -5, -1.5, -1.9, -1.99. And what I'm going to have to do is I'm going to have to take each of these and then plug it into the equation and see what answers I get. Okay? Let me do an example for you. So let's say, for example, I want to plug in -2.1 into the equation. I go to my fancy calculator. Come on, fancy calculator. Right? And I actually have it right here at the top. I can redo it if I wanted to. Second entry. So you see right here, I have -2.1 squared plus 6 times -2.1. Is that the right equation? Yeah. And plus 8 divided by -2.1 squared minus 4. Yes? I hit enter, and that gives me an answer of -4.63. So that's going to be -0.463. If I plug in -3, the answer is -0.2. If I plug in -2.5, the answer is -0.33. If I plug in -2.01, the answer is approximately -0.4995, approximately. If I plug in -1, the answer is -1. Plug in -1.5, negatives. Again, I did all of these on my calculator already. 1.9, 0.53, 1.99. I'm missing a negative, sorry. That's going to be negative 0.5003, right? And so my question to you is, if you look at the y values right here, what number is squeezed in the middle? What will be the limit of the expression? Can anybody make a guess as what that limit is going to be?
-0.5.
-0.5. And so that comes back, to the question I was asking. So initially, when I had this function and I tried to plug in -2, I did not get an answer. But if I take the limit at -2, I do get an answer, -0.5. And I'm listening.
Because I remember from like last time you said that the limit, like whenever you graph it on that chart you just did with X and Y, like it has, the limit is the number that they both have in common. So I'm just.
Not that they have in common, the number that completes the pattern. These sets of numbers are getting closer and closer to a number. That number is 0.05. These numbers down here are also getting close to a number. These numbers down here are also getting close to a number. That number is 0.05, -0.05. And so we say the limit is that number.
Okay.
Okay?
Yeah.
And the whole point of this right here is that this limiting process sometimes allows us to get beyond this impossibility. When we're saying undefined, what we're saying is that there is no answer. Well, this limit actually takes the place of this undefined and actually can give us a number in certain situations. And those situations are whenever we make a table of values, when we look at the y values are squeezing towards the same number. Okay? And that's why we're doing limits. Because it has the ability to get beyond dividing by 0. Any questions there? So let me review this process. Oh, go ahead. Somebody had a question.
I said nah.
Oh, he said nah. All right. So let me review this. Process quite quickly. The question started out this way. The question started out was that f of x is equal to, I think it was x squared plus 6x plus 8 divided by x squared minus 4. I think that's what it was. And then I said find. And then I gave you this mathematical expression. Okay? This small amount of language is actually asking you to do a lot of work. This small amount of language is saying number line. What comes at the center of the number line, somebody?
-2.
-2. I have to consider the left side of -2 and the right side of -2. I started a number away from -2, and then I walked towards -2, plugging these numbers into a table of values. Then I start on the right side of -2, plugging in these values, and looking to see again the y values and see if they are squeezing towards the same number. Questions there? All right. Since we have no questions, let's go ahead and try one for me, please. For f of x is equals to 10x plus 5, find the limit as x approaches 3 for the function f of x. Go ahead. When you finish, write the answer in the box for me, please. Give me 1 second while I look at it. Unless, of course, you have a question.
I'm confused. I'm not gonna lie.
All right. What seems to be the problem? Where we got stuck?
All I got is a number line.
Mm-hmm.
I was driving while you were explaining this, but I was trying to get back home.
Mm-hmm.
So
What numbers do you have on the number line?
I got 2, 3, and 4.
2, 3. You have to find numbers. Now you have to find numbers in between 2 and 3. The numbers that are approaching 3.
Both of them?
Say again?
What, like?
So where's my pencil go? So See number line right here? You got your 3. You have 2 over here. What number does that represent right here?
2.5.
So 2.5. And then over here, what number would that represent?
2.9.
2.9. And then right here, what number would that represent?
2.99.
All right, 2.99. And you do the same thing on the other side of 3. And you put those in a number line on a table of values and plug them in.
Wait, so after you do the left side, you draw your table.
You have to
And
do the right side.
so you
go
do the
ahead.
right side after you do the left side, and then you draw a table?
Yes. And on the table, you put all those numbers in. So x comma y, plug in 2, 2.5, 0.9, right?
Mm-hmm.
9, and then numbers on the other side, 4, and then so forth and so on. You plug all of them into the equation.
Oh, okay. That makes sense.
And it's 2 more points on the right side, right? Or is it to do the same thing?
That's a question that students always ask, and the correct answer is you gotta keep going until you can see a pattern.
Okay.
Normally, that it's about 4 numbers on each side.
All right.
Sometimes,
So like
go ahead.
on your graph for X or Y, how you have on the left side the X is 2, 2.5, 2.9. I know those are numbers that you're trying to get closer to 3, but like how do you like so where you have 2.99, how can you figure out like if it's like how do you know what number is like after 2.99? Because it just keeps
Add
going
another,
up and
they just add a 9, 2.999.
you do that. So what if like the number was you just keep doing that with any number, like it's always going to be the number 0.5 and then 0.9, 0.99, and it's always going to do that.
Yes, on that side. On the other side, it would be 0.1 and 0.01 and 0.001. So you see right here down here how it's 0.9, then 0.9, then 0.999. On the other side, it'll be like 0.1, then 0.01, then 0.001, and then 0.001, and so forth and so on. Okay. Yeah, so on the other side, 4, this number right here would be 3.5. And the next number down would be 3.1, right? And then 0.01. And then you keep adding zeros, 3.001, and so forth and so on. All right, I have 1, 2, 3, 4, 5 people answering. Come on, people, please step. Let me know.
So now you want us to plug all those X's, well, using the calculator, plug all the X's, plug it into the equation and tell you all the Y's? That's what we're doing right now?
Exactly.
Okay.
Maurice, how can I help you? Where we stuck?
So like where it says like the 4, you said something about 3.1.
Well, yeah, so the next number in line here would be 3.5. That's this one right here. And the next 3.1, the next one would be 3.01.
Oh yeah, I got you.
Oh, people now.
I'm doing this and it just looks wrong. So I'm just gonna wait for you to do it.
No, don't tell me what's wrong. What's wrong?
It just the numbers are so big. They don't look like what you had before. Because I did the first one, I plugged in 2.
What you got?
And I got 25 for my Y.
That is good.
Okay, cool. It just looked really wrong. Okay.
I have a question.
Mm-hmm.
Why'd you do 3.01 but not 2.01? Or is that it don't matter like that?
It does. 2.01 is actually right here on the number line. That's not very close to 3, is it?
Oh.
Yeah, that's why the number line matters. The numbers have to fit on that number line in a way that makes sense. That's why I cannot use, say, for example, 10.01. That's not going towards 3.
Mr. Maurice,
Mm-hmm.
I have a question. So after you do the table and everything, how do you determine what the next step is after you plug in all the numbers for the y?
You have to look at the y values and see if there's a pattern developing. Is there a number that's squeezed in between two sets of values? If there is, that number will be a limit.
Okay.
It's
Just type it in there and see if you have it in the thing. So you want me to
oh.
try those numbers? Those numbers I got, Miss Lawrence. For I'm guessing you plug in 2.5, 2.9, 2.99.
Yeah, I just feel like
Yes.
I'm doing it wrong.
Miss Tatiana, that answer is correct. Who feels like they're doing it wrong?
Me,
Who is me?
Rodney.
Rodney. All right. What do you have so far, Rodney?
I finished all the Y's.
Mhm.
I just don't know how to find, because you said you got to find the final answer. I'm just trying to figure out what to do from that point.
All right. So if you look at your y values, when you plug in 2.999 and look at plugging 3.01, right?
Okay.
A number between those two.
All right. Hold on.
Oliver, what are you saying the answer is? See a lot of numbers there. They all look just fine to me. What are you saying? What are you saying the answer is though? Xavier, that is correct. Maurice? Yes, Mr. Oliver, that is right. Maurice, the answer is not right, Mr. Maurice. Rodney, that answer is not right. I'd be interested to know how you got that answer. All right, so I'm running out of time, so it's my turn to work it out. So starting from this stage right here, going to the table, I have to plug in each of those values. When you plug in 2 in this equation, you get 25. When you plug in 2.5, you get an answer of 30. When you plug in 2.9, you get an answer of 34. When you plug in 2.99, you get an answer of 34.9. I actually plugged in 2.999. You didn't actually have to, but I did, so I'm going to put it in as well. 2.999, I got 34.99. On the other side, I plugged in 4, I got 45. If I plug in 3.5, I got 40. 3.1, I got 36. 3.01, I got 35.1, sorry. I also did 3.001, and that gave me 35.01. So what number, let me see if I can make some space.
35.
So what number lies between 34.99 and 35.01?
35.
And that is how you find that limit. That's that last step right here. You have to use a little bit of intuition.
Yeah.
So you finding the whole number, not like a point.
No, remember the last time it was a decimal, it was negative 0.5. It's not necessarily a whole number. Obviously, in this class, I'll try to make it a whole number to make your life a little bit easier. But that right here, that's your limit. The answer to this problem is 35.
I have a question.
Yes.
So I did it wrong in my head, but I still got the same answer. Like all I did was just plug the 3 into the 10x plus 5, and I still got 35. So
We'll get to that in a second. The reason why technically that is not correct is if you see I come back right here to this problem right here. If I was to plug the number, so I'm taking a limit as x approaches -2. If I plug -2 in, the answer I get is undefined. And that's not the right answer, correct?
yeah.
So technically speaking, you cannot actually plug the number in.
Okay.
Okay? When you're taking a limit, technically speaking, you're not allowed to, but as we'll come back to Lucy in a second, what you actually performed was a shortcut. But we'll get that in a second. So I do need to